Hello, Matt. All right, can you guys all hear me? If you can hear me, just throw something up in the chat box just so I know that everything's working. Perfect. We're gonna wait a few more minutes to see if anybody else shows up. I do see a few names I recognize, so it's good to see you guys, Matt, Stefan, Chris. So I have you guys on mute, but if you want to say something at some point and chime in, let me know, and just send me a message and I can unmute you. By the way, all of you guys should go see Kristen's presentation from NI Week. I think it's pretty awesome on clean code. I think that should be required viewing for everybody. So I haven't seen the video yet, so I don't know if it actually made it out or not. Let me go back. We're gonna wait 2 or 3 more minutes and then we'll get started. For those of you who just showed up. All right, we're going to go ahead and get started. Before we get into the topic for today, I just want to follow up from the last presentation. So my last presentation was on choosing a framework, right, and comparing the framework and the DQMH. And the actor framework has a class officially from NI. DQMH also has a class. It's not officially from NI. But I was planning on offering it. It's a class that Fabiola put together. The class is 3 days long, about $2,400, and it's going to be here in Golden, Colorado. So if anybody is interested in attending that, send me an email and let me know. I'm trying to get enough people together so I know it's going to happen before I go reserve a room somewhere. So send me an email and let me know what dates do or don't work for you. And if you need a certain amount of time to convince your boss to pay for it or whatever, let me know that too. All right, so I see a lot of familiar names. Many of you probably know me, but for those of you who don't, my name is Sam Taggart. I own a small company in Golden, Colorado called System Automation Solutions. And we're all about helping LabVIEW teams to be more efficient and effective. And I'm sure most of you guys know that most LabVIEW programmers aren't computer science majors, right? They don't have a programming background. They're just engineers and scientists. And they're really smart, and they do okay at writing really small programs to, collect a little bit of data from an oscilloscope or a card or something and display it. But the problem is that then those programs get to be more and more complex, right? And without a software engineering background, these engineers and scientists, they have a hard time managing all that complexity. And so that's where we come in. We help these scientists and engineers manage all that complexity by teaching them some basic software engineering principles and tools and methods. And one of the tools that we use is unit testing. So that's what we're going to talk about today, is unit testing, specifically using a tool called JKI VI Tester. How many people are familiar with JKI VI Tester? You guys can throw that in the chat. I kind of have you all muted at the moment. All right, I see somebody raise their hands. No. How many of you guys are actually doing unit testing, perhaps using something else? Maybe unit test framework or Karaya, or there's another one, Peterbilt Core's Insta Coverage, I think. Are you using any of those? Okay. All right. Okay. Yes. So JKI VI Tester is not officially from NI. It's from JKI, as you might guess from the name, but it is pretty mainstream and it's pretty well used out there. I would say it's probably the most popular one. If you're not using unit testing, that's fine. That's where we all start, right? Nobody starts out doing all this process stuff. We get into it because we see the benefits, and hopefully by the end of this presentation, you will see some of the benefits and it'll motivate you to at least take a look at it closer. All right, so for reference, all the stuff I'm going to talk about are ideas I got from reading this book. I'm going to be kind to you and tell you that this is a 900-page thick book. I asked Nancy what the best book on unit testing was, and she recommended this, and she didn't tell me it was 900 pages. And I ordered it. I got this package on my front porch that I could barely pick up because it weighed like 10 pounds. So it's a big, thick, heavy book. I've tried to distill out as much as I can. There are some other good books. I'll type them real quick in the chat. These are not books that I've read, but they come recommended from people like Crab and some others. They're sitting on my desk actually right now. Once I recover from reading that 900-page book, I will probably start looking at these. I will tell you they are definitely much skinnier. I think they have like maybe 200-300 pages a piece. So they look to be much easier reading. This X-Unit test pattern kind of reads like a textbook. But it's got tons of really good, deep information in it. So hopefully watching this will save you the trouble. All right, so this is what we're going to go over. We're going to go over our unit testing overview. Why would we use it? What are some of the basic ideas? Then we'll talk about JKI-VI tester in particular. And then we'll talk about techniques for writing testable code. So you'll find that there are certain types of code that you may write now that are difficult to test. And we're going to present some techniques to try to make them a little bit easier to test. So some code is really simple and easy to test. Like a simple VI with inputs and outputs, that's really easy. When you do stuff like updating a GUI, talking to a database, talking to hardware, things like that, talking to a serial port, excuse me, it gets a lot harder to test things. And so we're going to give you some techniques for writing your code in such a way that it's easily testable. Any questions so far? All right, so there's basically two types of tests. There might be a third called like integration test that kind of fits in the middle, but for the purpose of this, basically, you've got your customer test, right? And the audience for that is your end customers. They help to define what done looks like. So, you know, first thing you do, right, is gather all the requirements, figure out what you got to do, but then you need some way to tell when you're there once you've finished the project, right? Particularly if you're a contractor and you do fixed price projects, this is really important, right? Because you want to be able to tell them, hey, look, we agreed this is a test that had to pass. It passed as a test, we're done, right? And then they can do. And generally, customer tests test entire features, top to bottom, right? So I enter something in the GUI, the machine goes and does something, generates a report. It's like a round trip, you know, test the whole thing at once. Generally, customer tests only execute the most common paths, right? They're not trying to get into every little path. And well, what if I get a little weird error over here or this or that? They test the most common paths. They run less frequently, right? Usually you run them once at the end. And they verify the integration, that all the little bits and pieces work together correctly. Unit tests are very different. The audience for a unit test is generally the developers. So this is something you write for yourself because it's going to make you more efficient at development. And we'll talk about how that happens. It seems kind of counterintuitive because you're like, oh, I got to do all this work to write all these unit tests. But it is going to save you tons of time later debugging for sure. But the audience is a developer. It documents individual modules. So it's not looking at the whole software system as a whole and how all the pieces play together. It's looking at one particular piece. And it attempts to execute all the paths. We want to know what happens if we get an error from our serial port back. We want to know what happens if our serial port sends us something and it's malformed. What does our code do? And we're going to run these daily or as frequently as we can. And the reason we run often is because when we introduce a bug, we want to find that bug right away instead of finding it a month later and then having to sort through a month's worth of commits to figure out, well, which change did I make in the past month that caused my problem? Somebody just drew an arrow on there. I didn't know you could do that. And they're used for defect localization, figuring out where the problem is. So if system's misbehaving, run the unit test, it should point you to the correct problem. And yeah, that will save you a ton of time on debugging. So this whole presentation is going to be more about unit tests. Excuse me. So unit testing goals, right? Unit tests can act as documentation, right? If somebody gives me a piece chunk of code and I want to know how to use it, I can look at the unit tests and it will show me what the inputs and outputs are and how to use it. You might say, well, I write lots of comments in my code and that's great. I'm not saying don't do that, but comments go stale. Right? You change what the code does, the comments never get updated, and now you don't know what it really does. With the unit test, they don't go stale because you run the unit test and either it passes or it doesn't. If it passes, it tells you exactly what the code does. If it fails, then you need to fix something. Unit tests work really well as specification. So somebody on this call, actually, I was talking to them and they're like, yeah, I pass work off to these people who worked with me, but I never really know how to tell when they're done. They bring it back and I don't really know if it works or not, or, I got to run all these tests and it's a pain. And I said, well, before you hand them, write the API, write a set of unit tests and hand it off to them and then tell them not to come back until the unit tests pass. And when they come back to you, the first thing you do is you run the unit tests. And if they fail, you just say, look, you're not done yet. You need to go fix this. And it makes it really simple. Defect localization, right? find bugs. Preventing recurring bugs is a big thing. So I picked this up from Fab and Alan and probably James and some other people as well. I've also mentioned this over the years, that if you find a bug, right, the first thing you should do is write a unit test that catches it. And then once you fix it, that unit test becomes part of your unit test suite. And every time you make changes to the code, you will never reintroduce the same bug because your unit test will catch it. And another thing that they do very well is act as a safety net, right? So if I need to make some major changes to my code, I can make lots of changes and know I'm not going to break anything because I've got my unit tests. So I make a change for my unit test, everything passes, great, right? More changes for my unit tests. And if at any point, you know, in that whole cycle, I break something, boom, I run the unit test. Oh, that change I just made broke something. I just roll that change back and do it a different way or fix it. 1 second. I realized I made a typo when I put the title of that book in there. It should be The Agile Samurai. All right, so that's our unit testing goals. And in order to do all this, our unit tests have to be automated in the sense that we can just press a button and run them. And JKI VI Tester gives us a way to do that. So we're going to talk about that in a few minutes. But first, you are probably already writing tests, right? In the case of Chris, who mentioned he's using some homebrew framework, right? He's already definitely writing tests, but the rest of you are all writing tests anyway, because, you know, you got a VI, you're unsure, you want to make sure it works right. You just drop in a blank VI, right? Create all the controls and indicators and type in some stuff and run it. Or you go to the front panel of the VI itself, you type in some stuff and you run it. And here's just a really simple test, right? This VI does some conversion on strings for a serial driver, right? So I've got a channel input, some command that I'm giving it, and a bunch of parameters. And I put it through this VI, and out comes a string that I'm then going to write to my serial port, right? And I want to make sure that it's formatting correctly. So, you know, I can open up the VI itself, type this stuff into the front panel, hit run, see what comes out. Okay, yeah, that's what I expected. Here, it's a little bit more automated in the sense that I don't have to know what, I have to put in what I think it should look like, but it'll automatically do the check for me. So if it's missing a comma or something, you know, me as a human being might not notice it, but this will definitely catch it, right? So we're going to take this a step further, and we're going to define, using VI test, we're going to say, okay, it's this VI with this set of inputs, this is what the output should be. And for this other set of inputs, this is what the output should be. And we're going to do that, and it's really nice. We're going to do that using code, actually. So when we get to that part, it'll be pretty exciting, I think. But first, I have to show you guys how to install and use JKI VI Tester. So if you don't have it installed and you haven't used it before, you can install it using JKI VI Package Manager. The one caveat is when you run JKI VI Package Manager, you need to run it as administrator, because when it installs, I guess it puts some stuff in places that it doesn't have access to, and so you need administrator access in order to do that. But if you just search for VI Tester, there's a JKI Labs tool VI Tester. That's the package you want. There's another one below, JUnit XML test results. That's just a package that you can use to format the results a certain way if you want. You don't need that. And so it's just like installing any other package from JKI VIPM, right? And once you install it, you'll notice that it shows up in your tools menu. So tools VI Tester, there are a couple options there. The test VI's method launches the GUI excuse me, to run all your tests. And you can create a new test case or test suite, and we'll talk about what those are in the next slide. I should mention, if you guys have any questions, feel free to throw them in the chat. I think I already said that. So the way the tests are built, we have this notion of test case classes and test suites. Okay. And really the lowest level thing is what's called a test method. So you have a VI that's part of a test case class. It starts with the word test. So test, my VI does XYZ, would be the name of the VI. And when you run the test, what happens is JKI Tester looks at the test case class, finds all the test methods in it, so all the VIs that start with test, and it runs each one. And before it runs each one, it runs this setup, then it runs the test method, then it runs teardown, then it runs setup, runs the next test method, runs the next, or runs teardown again, and it keeps doing that. So we'll run every one of those test methods once. And you have the setup and teardown if you want to do something before you run every test method or after you run every test method to make sure you're cleaning up resources or whatever you have to do, you can do that. And then a test suite is really just a collection of test case classes and or test methods. So for example, the best practice, what I've found is the best practice, and somebody else who has more experience can contradict me on this, but I like to create, at least in the beginning, create one test case class for every class or library that I would create. So I create a class or library, I've got my public API, right? And I've got a bunch of private methods inside that class or library. And I create a test case class, and it exercises all of those API methods, all the public methods for my class or library. Right, so there's at least one test method for each one. There's usually multiple. So it's like test, name of my VI with this input should do XYZ. And my test method names get really long, but they're very descriptive. So that I find that quite helpful. So I've got one test case for each class that I've created or library I've created in my project, each module. And then I have a test suite that collects a bunch of those and says, all right, these are the ones that I want to run every time I check in my code, right? And that might be a subset, because maybe every check-in I don't need to check everything, but then maybe before I do a build, I want to check absolutely everything. So I might have like a comprehensive test suite that's like every single one, and I might have something called like a smoke test suite that just tests a handful of things that I think are really likely to break or super important. So you can play around with that and do different things there. All right, oh, one other thing I should mention. So inside this tcsimple.lv class, this is the test case that I created. This is what it looks like right when you first create it. You get the class, got some private and protected methods. It's got a setup, a teardown, this test example VIT, and temp VI under test. So the test example, that's what you want to use as your to create your new test methods. So if you right click on that and click on new from template, you'll get something like this. And you've got this test case class in, and this contains all the data about whether the test passed or failed, right? So don't fork that wire, that's important. And then we've got our temp VI under test. This is VI we're testing, it outputs a string. In this case, we expect the result to say dog. And we're passing them both into this equals method in the middle that then determines if those two are equal or not. If they're equal, the test passes. If they're false, if it's not true, then it fails. And there's a whole palette full of those assertions, like the equals, and I'll show those to you in a minute. That whole thing is inside a disabled structure. So in the disabled case, there's a VI in there that's a skip. So if you want to skip that test for any reason, you can just go in and flip the disabled structure, and it will skip that test when you run. So maybe you've got a test that's causing problems, or one that, you know, for whatever reason you don't want to run, you can just go in and skip it, which is much nicer than like going in and doing something else like deleting it or something like that, because then the test is still there and you can always decide to unskip it later. Maybe when you're debugging too, sometimes maybe you want to skip a bunch of tests because they take way too long and you know you just want this one test or something like that. All right, so that's what you get out of the box. I recommend you do something similar to this. So this is called a 4-part test. This comes right out of the book, and it's got 4 steps. It's got setup, where you open any resources that you might need. I did forget to mention that, Chris. So that is very good. Yes. So yes, take Chris's advice and remove compile code. Yeah, there are a lot of problems with the template the way it is. I haven't quite figured out a better way to do that. So, but yes, definitely do that. Generally what I do is I change that, I create the first test and then just delete the template and just copy a previous test case and then fill in the insides. James McNally, I saw a presentation of his at the CLA Summit in Madrid. He had this 3-part test. If these are the input conditions, then when this thing happens, then this is what we expect. So this is kind of similar. It adds a 4 steps. So the setup is opening references. Exercise, the only thing I put in there is the set. I call it the set, software under test. And that's the VI that we're testing, or method that we're testing. And so by putting just that in there, then I know exactly which VI I'm testing and what I'm trying to verify. And then the verify, I just put the assertion methods that say, hey, these are things should be equal, or this should be greater than this, or whatever I'm asserting. And then the teardown is the cleanup phase. And it just makes it really clear to somebody reading your test. You know, if I want to know exactly what I'm testing, I look at the exercise box and I know it immediately. So, any questions? The teardown part and setup part, like, you don't always need it, but I just always put it there just so it's clear. And you know, you can mark it an A or just leave it blank. I have like a little VI that like drops the content, so I just put that in one of those and put it on the ballot, and I just drag it and drop it. So it's really quick and easy to get started. I highly recommend you do something like that if you're going to get really into this, because you'll get tired of drawing out those sequence structures all the time. For loop and a case structure, you could do that too. That is totally doable. I just feel like if you do that, it kind of hides stuff. And in theory, your test, you want to make your test as short and easy to understand as possible, because the problem is, if you make them really complicated, then you have to test your tests, and then how do you have test your test, and it just goes off down the rabbit hole. So by making your test as simple as possible, then you kind of avoid that. So, and being able to see it all in one picture, I think, is also useful. I don't know if there's anything wrong with using a for loop in a case structure, but I personally wouldn't. It will certainly work. Okay, so where do we get all these assertion methods? When you install JKI VI Tester, you get this, in the palette, you get this JKI toolkits. And there's a whole bunch there. Fail, just straight up fails. Fail if, you know, you pass in a Boolean. If it's true, it fails. Fail if equal, pass if equal, pass if error. There's a few other things you can do there. If you want something more specific, so those all work, and they work in general cases, but James McNally decided that they weren't quite good enough for him, because he things like, if I compare an array, I don't want it to just tell me the arrays aren't equal. I want it to tell me like which element of the array is not equal, right? And so he has this thing, he calls it VITAC, VI Tester Advanced Comparisons. It's on GitHub. You can go look it up and you can go install it, and it adds another palette for you. I saw today he announced that it's on the LabVIEW Tools Network now. I don't know. I know James set up for this. I don't know if he's actually here. But anyway, congratulations. I think that's pretty cool. I know how much work it is to get something on the Tools Network, so it's a pain. So it's cool that he took the time to do that. So you can drop all these in to create your assertions, which basically say, hey, look, these two things have to be equal or not equal or whatever. And that's what determines if your test passes or fails. All right, so how do I run tests? Well, there's two different ways. You can do it programmatically. So at the bottom, right, in your palettes, there's JKI Toolkits, VI Tester. Under Tester API, there's something called Run Tests, and you pass it an array full of tests. I think you just pass it the paths, and it'll output the results. So that's useful if you want to do something like continuous integration with it. The other screen up there is the GUI. Cool. So Christian pointed out that there is an article. I don't know what CoSys is, but I will go look at it. Modifying the templates here, given when then. Oh, well, Christian just sent it to me. Okay. Well, I will. Yes, go ahead and share that, Christian. That's awesome. I'll let you share it. Perfect. Thank you. So, and then, excuse me. This GUI screen there is if you go to the tools menu and you go down, I remember if I told this, but JKI VI Tester shows up in the tools menu, and there's something, I think it's called test VIs or something like that. It pops up this window, and you can see the hierarchy of all your tests. So in this example, I have one test case that's got a test example 13 and a test simple test method in it. And when I click run, it will run those. Okay, I'm sure they could all figure that out, Christian, but thank you. That is great. Thank you for sharing that. And so you run the test here and it'll tell you exactly which test fails, and it will, under test failure data, it will tell you what test failed. So. All right, on to the next slide. Okay, so there are a few things we want to avoid when we're writing tests. Number one is over-specification, right? So we want to have tests so we can make changes to our code, right? Know that we didn't break anything. But if we test absolutely everything in our code, if every VI in our code has a test for it, then when we change that one VI, now we have to change the test for that VI, and it's a huge pain. So what I like to do is I test at the class or library level, and I just test the APIs. So then anything that's private to the class or library, in general, I can change that all I want. And all I care about is that the API is still the same. You avoid fragile tests, so tests that just break all the time. And if that happens, that generally means that you're depending on some features of the software that you're testing that aren't part of this particular test, right? And so you might be testing feature A, but to do it, you need to set it up and use something out of feature B, right? And so then when you change feature B, you expect all the tests for that feature to change, but then all of a sudden these other tests change as well and break. You want to avoid slow tests. So like, you might have something that uses a database and you're like, oh, it only takes a second or two to query the database, and that's fine. But if you're doing really trying to get lots of test coverage, right, you might write 50 or 100 tests to test the database, and if each one takes a couple seconds, now you've got a problem. You really want to skip and avoid hard to understand tests. So if they're overly complicated, if they're testing too much, if you've got a bunch of loops and stuff going on in your test, probably not what you want to do. Because again, you don't have any tests to test your tests, and you don't want to go down that rabbit hole. For the same reason, you don't have conditional test code. So like case structures in your test code is generally a bad idea. You want to avoid duplicating test code for the same reason you avoid duplicating code anywhere, right? Because if you find a bug in it, then you got to find everywhere you used it and change it. It's a big pain. So we can refactor that to use sub-VIs. You can use the setup and teardown, right? So before each test method, it'll run a setup test method and then tear down before it runs the next test method. So you can use those and put some common code in there. And you want to avoid test logic in production, right? So if you've got your production code out there, you don't want somebody accidentally toggling a Boolean that then all of a sudden tells it to, like, just report back that everything passes or everything fails, or, not read the serial port and inject some random stuff, right? So we want to do stuff where, like, we're calling from our test code into the production code, but the production code doesn't know anything about the test code, right? That's what we want to have happen. All right, so there's this idea out there called test-driven design, and it gets a lot of press and lots of people talk about it, and there's lots of books on it. And basically, the idea is when you add a new feature, you're designing new code, you write the test first, right? So you decide what the thing's got to do, and then you write tests, and then you write the test, and you run it, and of course, it should immediately fail because your code doesn't do anything. And then once you verified that, then you verify that you don't get any false positives, right? Then you start writing your code, and then the test passes, and that's great. And you want to add another feature, you write another test, then you add the code to test that feature, or to make that test pass. And then the idea is that you write better code because you're writing code that is testable, and it makes your code simpler and easier to understand. And I lost my train of thought for a second. Oh, shit. Whew. So your code becomes easier, and then, wow, I just completely lost my train of thought. Never mind. All right, we'll move on. Humble objects, right? So the test-driven design, it changes the way you write your code because you're trying to write it from the very beginning so that it's easier to test, right? So if you ever inherited legacy code that somebody else wrote, you look at it and it's very hard to test because everything is tightly coupled, right? And you can't just pull out pieces and test them in isolation. So Humble objects is about pulling out the logic that does the calculation from the hard to test code. So for example, if you have a GUI, right, and you're updating the GUI, if you've got a bunch of logic in there, you can't guarantee that what's being displayed on the GUI is the correct value, because you can't test that logic without testing the GUI, because it's all part of the same VI. But if you take that logic and make it a sub VI, then you can test that sub VI, right? And then you're trusting that, okay, yeah, when I write to the indicator on the front panel, it does what it's supposed to do. But you know, unless there's some weird bug in LabVIEW, that almost always happens. And then we also have this other technique called test doubles that we're going to talk a lot about, that allow us to manipulate indirect inputs and outputs. And what do I mean by that? Well, direct inputs and outputs are things that we can look at from the connector pane, right? So we drop our sub VI, it's got 3 inputs, it's got 2 outputs. We can immediately access those, right? And we can manipulate the inputs and see what the outputs are, and everything's fine, right? But sometimes, right, for writing to a serial port, for example, we send some inputs, and right, those inputs nothing comes back, right? We're just writing to the serial port, right? So it's got some side effects, I think is one of the terms that people use in other languages, right? So this function has side effects that you can't directly see. And maybe if you're reading from a serial port, again, there's no inputs, you're just getting text back. So, you know, how do you verify that? So we're going to use test doubles to do that. All right. So here's an example for humble objects. This is a non-humble object, right? So this is a serial driver for a device. I just made this up, but a command, a couple parameters in a channel that come in, right? We're coercing the channel, we're creating a string, we're adding all the parameters, right? We're adding a terminator. How do you test that that writes the correct thing to the serial port, right? If we use our previous example, right, where we've got our four-part test, we can drop this VI in our 4-part test, but how do we know that it's actually doing what it's supposed to be doing to the serial port? Right. So we can use test up for that. We can also use a humble object. So we'll do the humble object implementation first. The humble object implementation is we create what's called a humble object for the serial port. And it's called a humble object because all it does is just write to the serial port. That's it. And we take all the logic that we were using to create our string that we're writing, and we pull it out into a sub VI. And now we've separated those two things. So now we can take this sub VI that does our string conversion, and we can take that and we can drop it inside our 4-part test, provided it's public, and everything should work. We should be able to test that. And then our humble serial port object, we can test that just manually once or twice with the actual, and say, okay, if we send a string up on the other side, okay, great. Then we don't have to test that anymore. That's not changing. That should probably always stay the same, right, and never change. And so we're good. We don't have to do anything else with that. Does that make sense to people? Okay, I see some yeses. That's cool. So you can do this with GUIs, you can do this with database, you can do it with all kinds of stuff. Yes, so we're going to get into that, Christian. So this method definitely works. I like using test doubles better. So I'll show you an implementation that uses test doubles. So ideally, I would make this whole conversion thing private, and I would use a test double. So I just wanted to show you the option because this is a really simple and easy thing to do. And you know, depending on what you're doing, you know, you may not care that it's public or private. If it's a top-level GUI, you might be able to add that and not really care at all. If it's part of like a module, I would definitely make that private and use a test double. All right, so here's how this all fits into our 4-part test, right? This is what you saw earlier. I just took that serial converter and dropped it into my exercise, right? And then whatever it outputs, I know what it's supposed to output, and I compare them. Any questions on that, how that all fits into the 4-part test? How are we doing on time? Good. All right, so test doubles, right? So Hollywood uses stunt doubles all the time, right? Because, you know, maybe the actor's very expensive. We don't want to pay him to do it. Maybe we're worried about him getting injured, right, for various reasons, right? And so You know, in the actual movie, the actor does all the acting, but when it comes time to do stunts, they pull in the stunt double to do the stunt, right? So in our software, we're going to have the actual object that's going to do all the work. When we do testing, we're going to have a different test double. And why would we do that? Well, some examples, maybe it's a big database and we don't want to query the database, right? Because it takes a lot of time. Maybe it's a high-level object or a program, we instantiate it. We have to instantiate all these other objects, right? And it takes up a lot of memory. It takes a long time to load, right? We can put in a lightweight version. So there's a variety of reasons that we might want to use test doubles. It helps us to test alternate paths in our code too. So that's something that we're going to look at in a minute. So we have 3 basic types, and you can kind of mix and match these. But basically, if we're just talking straight test doubles, we have a responder, right? And that's the one on the bottom left. And basically, all it does is it outputs valid data. So it acts like the set to output valid data to allow our test to continue. So if you had something that like read some data from a serial port and did some other stuff and then output something, you would use a responder, right, to output valid data. So that data allows the rest of the processing to continue, and then we check the output. A saboteur, yeah, I guess that's how you pronounce that. I'm not French, but it injects errors or incorrect data, right, to the set to verify the error handling. So that's something that's hard to do, right? Normally, right? Say you're talking to some serial instrument, you know, well, what happens if the serial instrument outputs something crazy, right? Well, without going and sabotaging the instrument, you can't really do that. But if you simulate that by using a saboteur, so instead of writing to the actual or reading from the actual serial port, you read from this saboteur that returns either an error or some misformed stuff, you can do that. We have something called a spy, which basically just says, in the case of the write to serial, right? So our program thinks it's writing to the serial port, but instead it's writing to the spy, and it's just dropping that in a queue, and I can examine the contents of the queue later. All right. So if this doesn't quite make sense yet, wait till the next slide. So how are we using these? We're using something called dependency injection, right? So your actual code, your production code, is not calling up, in this case, a serial port, right? It's not calling up your humble serial port directly. It's calling up this iSerial, right? interface. So it's calling up the serial interface that knows how to read and write data, right? And normally in production, it's using the humble serial port. So normally the data is actually getting written and wrote directly from the serial port. But when we're testing, because our code only knows about iSerial, our production code, we can inject a spy or a saboteur or a responder in order to manipulate those indirect inputs and outputs. So the data that's coming and going from the serial port, we can simulate all that using one of these test doubles. Does that make sense to people? Did that confuse anybody? Hopefully everybody's somewhat familiar with object-oriented programming and how that works. All right, if I lost you, that's fine. Just let me know and I can go back over to try to explain it a little bit better. All right, but the key is dependency injection, a bit lost. Okay, so let me see. I don't have an example from the parent clause. So our parent code, okay, say we go all the way back. Yeah. Let me see. Right here. Okay, so Sergio. Hopefully this will explain things. Here I have my serial driver, right? And I've separated it out, so now I have a humble serial port. Okay. And when I write data, I'm taking the information, I'm converting it to a string, I'm writing it to the serial port. Are you following me so far? Okay, perfect. Now, if instead of, I hit the button, sorry. If instead of a humble serial port, this serial driver owned a iSerial serial interface, right? That also has a write to serial port, okay? We could still write this code in this, down here where it says humble, right, the write humble, it would change to write iSerial, right? But it's still a write string, right? It's still got the same connector pane, right? It's dynamic dispatch. Do you follow me so far? All we're doing is changing out the humble serial port for an iSerial. Then before we call this, and we have to do this in both parts, before we call our serial driver anywhere in our code, we tell it what type of serial port we're using. We tell it that we're using the humble serial port, which actually reads and writes to the real serial port, or we tell our code, hey, we're not using that because we're testing, so we're going to use the spy or the error or the saboteur. And each of these then overrides that right to serial port to either to do something. Does that kind of make sense? Okay, perfect. I'm sure you're probably not the only one. That can be a complicated thing to understand. But once you get it, it's a really powerful technique. So highly recommend it. I'm glad that worked, you, Jonathan. Perfect. Yes, Actor Framework does a lot of dependency injection. Yes. I'm going to say the abstract messages are the #1 example of that off the top of my head, but I think I use it some other places too. So, yep, it takes a little bit to wrap your head around that, but if you don't do the dependency injections, particularly in Actor Framework, you end up with circular dependencies and it gets really bad. So definitely you want to learn about that if you're going to try to delve into Actor Framework. Okay. All right. Well, I'm glad that was useful. Yes, exactly. Yeah. So some of you guys might have already done this, right? If you learned about object-oriented stuff and you're like, oh, I can have my DMM and override it with the simulated DMM, it's exactly the same thing. I have not found a way to do that yet, Christian. I don't know that you can set default values on objects, but it's really hard and difficult to know exactly, like, if you run a VI, right, and it's got an object terminal, and then you right-click on the object terminal after you run it, right, it's still got the value of whatever was passed in, you right-click and click make default, that will do it. But then it's really hard to know what that is because it just changes color, but then you have to figure out what, so it's really complicated. I have not figured that out yet. Maybe somebody else has a better solution to that problem. So yeah, you do have to make sure that you set it correctly, right? So in your production code, you actually have to add a thing at the very beginning that says this, use the production serial port driver. I'm trying to think, you could do things like the parent class could throw an error every time it's called and then you would catch it, right? So if you forgot to set it to the right one, it was just using the parent, then you would. So, all right, so using test doubles, right? So here's a test double. We're testing our serial port read, right? So I've got my responder class, and I'm setting in my responder class, I'm setting the data that I want to come back out. I'm setting the status that I want it to spit out. And then I'm taking my driver for my instrument. I'm saying, what type of serial class am I using? So I'm using the responder. And then here I'm the SUT, the thing that I'm exercising, right, is calling the read on my driver. And it's outputting a status and a data. And here I'm comparing them both to make sure that they're both equal. And here I'm just closing the driver and exit, right? So everybody kind of see what's going on here. So inside my SUT here, inside my read driver, I'm actually calling not the humble serial port reader, but I'm calling the responder, which is going to respond with whatever I told it to respond with. Questions? Those of you who are having issues with dependency injections, that kind of makes sense that I have to tell my serial driver which serial port to use before I actually call the method that I want to test. Yes, you can definitely do that. So yeah, if for a particular test case, you want all of your test methods in there to use the same test double, you can install it in the setup. That is totally doable. In this case, this particular, the responder is actually programmable, right? So it doesn't just always respond to the thing. I pass it different data and status for each test to tell it what to do. But if you had one that just always injected an error or always returned the same thing, it would be really easy to do that. Here's another example. Right here, I'm passing in the error one, and I'm doing my write in this case, and I'm verifying that I should get an error out. So you use the global test. Okay, so it's worth noting there's the setup and teardown, and there's a global setup and a global teardown. The setup and teardown gets run, so you have your test case class, which basically is equivalent to this. This is a class full of tests to test my API for this particular class. And you've got a bunch of test methods in there, and you've got a setup and a teardown. So the normal paradigm is, right, when you run that test case, JKIVI tester looks at it, picks out all the test methods and says run setup, test method, teardown, setup, test method, teardown, setup, test method, teardown. There's an override you can use called global setup and global teardown that will just run once before all the test methods, and then the teardown runs once at the end, the global teardown. And Stefan is saying that that doesn't pass data to the actual test, and that I don't know. I don't know that I've tried to do that. So one thing I would say you could do, Stefan, to get around that is just use the global variable inside that test case, right? So make a global variable inside the test case, and then your global setup right to that, and then you can pull that off in your other test methods. Generally, I'm not a huge fan of globals, but in that case, I think it's a perfect use, and it's scoped inside your test case, and so it shouldn't be a big deal. I want to say I actually looked into that, and it has something to do with how all the objects are created behind the scenes, but yeah. That's the workaround. I want to say if you just call regular setup and teardown, that you can store stuff inside the object. So you could have inside your test case class, you could have some data member, and you could set whatever that is inside your setup, and then you could read it in your test method. But the global setup and teardown might not allow you to do that. Because I want to say it creates a whole new object for each setup, test method, and teardown. That creates a whole new object. Yes, okay, exactly. That, okay, yep. Yeah, so that's the problem with using the global one, but you can, I think that's more intended to use things like if you're going to use a database, like that populates the entire database at the beginning or writes a file or something. I don't think that's actually intended to be used to create stuff and then pass it from one to the next. Okay. So that's good. I'm glad my understanding of that was correct, because I looked at it, I didn't dive too deeply into it. And hopefully that didn't go over everybody else's heads. And if it did, you probably don't need to worry about it. Oh, so that's the error, and here's the SPI. So for the SPI, right, we're going to use the SPI serial port, which just writes the data to a queue. So the first thing I do is I create the queue, I give it to the SPI, and stick the SPI inside my serial driver. And then I call write, right? So I'm writing the data to the serial port now. And my driver is not using the actual serial port, it's using the SPI. And that drops it on the queue. And so then in the verify step, all I have to do is read the queue, which should have all the data on it. And then I can say, okay, well, what do I expect to be written to the serial port? And does it match or not? Then I close everything down and I'm done. You probably do want to be very careful about closing references here, just because if you've got, you know, a huge test suite with, you know, a couple hundred tests and they all leak a reference, you know, you're going to use up a ton of memory pretty quick. So any questions on how this one works? Yeah, it's slightly complicated, but I do feel like having it in each separate section makes it really easy to tell what's going on. So even though there's a bunch of stuff going on, it's really easy for me to look at the exercise thing and say, oh, I'm exercising this. Another thing actually that's useful is to right click on the VI that you're testing and click on show label, and it will show exactly what the name of the VI is. That sometimes is just really easy, because then it's easier to find it in the project. Generally, I don't ever do that, but this is one place where I think that sometimes makes sense. All right. So we're running up on time here. We got like 10, 15 minutes left. So some other test double types that you might consider using in-memory databases. So if you have a big, huge database, they are all just made up examples, but I can probably zip them up and send them to you guys. Let me make a note to do that. You will see that they are all, there's really nothing behind any of those BIs, but if you think they'd be useful, you can certainly have them. So other test double types, right? So in-memory databases. So you got a big database, right? And you want to test some stuff that makes calls to the database, right? So you can do the humble object, right? And try to extract all the logic that creates the SQL queries, and that's good. But maybe you actually really want to use a database. You can use SQLite, and you can create an in-memory database, which is super fast. And as long as all your queries are just SQL, then it'll work fine. So if you're not using anything that's esoteric or specific to whatever database you're actually using in production, that works really well. And also you can populate your database. So if you got like 10 gigs worth of data, your SQLite database that's in memory might only have like, a couple hundred megabytes, because you might just put in a couple files just to test a couple different cases. Another test double type that's really useful is a mock object. So our SPY, right, inside we were extracting the data that was written to it, the inputs. A mock object, when you make a call to it, it just logs. It says, hey, this was the call that was made, this method, and these were the inputs. And so there are some cases where that's quite useful. They're actually rather difficult to create in LabVIEW. I'm working on a tool to do that. And so if any of you guys are coming to the CLA Summit in Austin, hopefully I'll have that ready by then. I'll be able to show that. And yeah. More information. There's a unit testing group on the NI forums. Fab's part of it. I'm sure James Mack is probably on there as well, because he's super into unit testing. If you find any of his presentations or his website, he's got tons of stuff. So does Fab. Alan's into it. There's a whole bunch of other places to get information. Okay, so wrapping things up. We'll do questions in a minute. I just want to get through this really quick. So some of you guys are probably here because you're just curious about unit testing, and that's really cool. And I hope you found all this useful and inspired you to go try some stuff. Some of you guys might be here because you're having specific issues or something that you would like some help on. Or maybe you're interested in getting some more coaching or guidance on how you could improve your software development process. Right. So for you guys, I put together a special offer. I'm calling it a brainstorming session. And basically what it is we do a couple phone calls. I try to figure out, based off your symptoms, what the underlying problem is. So if there's some underlying thing that we can fix. And then once we figure that out, then we put all the stakeholders into a room. We sit down, we do a brainstorming session, and we come up with a set of actions. We come up with this action plan that has some metrics and some dates and some owners, so we can actually make some progress on this. And the nice thing is, I try to make it so that the stakeholders come up with all the ideas. So I throw ideas out there, and then they pick the ones that they think they can do. And then there's a lot of buy-in. So like, it's not like me coming in and saying, this is what you have to do. It's more, here's some ideas, pick the ones you guys like, and I'll help you implement them. So you come up with this action plan, and then we do a couple follow-up calls, right? So if you have any questions or you run into some obstacles or you're like, I'm not quite sure about this, then we talk about that and fix that. So it's $1,200. There's a QR code there. There's a bit.ly link. If you're interested, go check that out. That's all I'm going to say about that. I'll leave that up. Who has questions about any of this? Did you guys find this presentation useful? All right, glad to hear it was useful. Oh, other question. I was going to send out a survey, but I'll just ask it right now. Compared to using the Join Me, was Zoom better experience as far as like the audio? Because I know like the Join Me audio was horrible. So hopefully this was better. I switched it up. I figured it was worth trying. I did not talk about how to test protected methods. So the steps are run in series using JKIBI tester. Okay, so Chris had a question about testing protected methods. So if you're testing protected methods, you run the risk of over-specifying your software, right? So they're protected because you don't want the outside world to call them, and the thought is you can change those and not affect things. Although if they're protected, you're counting on child classes to do stuff. So you don't want to test, so our Shep, whoever that happens to be, Ryan Shepard probably. Yeah. Okay, thank you, Christian, for feedback. So testing protected methods, right? Normally, the stuff that you want other code to call, you make public, right? That's your API. And then you encapsulate everything else by making it private, so then you can make changes to all the private stuff, right? And the rest of the world doesn't care, so you don't break everybody else's code. Protected is a little gray area because you make it protected so your children can call it. So if you make a change to it, you could break some of your children, right? But it's still protected from the outside world. If you need to test those, I recommend not testing them. But there may be some cases where it's like a plugin architecture and you want to make sure that that protected method does what it's supposed to do, so that if your children call it, it does the right thing. What I've done, Chris, is create a child class and create a method, call it something else. But basically, it's just a wrapper for the protected method. And that method is public for the child class. And then in your test, you know you're using the child class, the test-specific child class. So then you can call that other method. And then you can get access to that protected method, right, through the wrapper. Does that make sense, Chris? Mr. Stryker? Maybe you have a better idea, or maybe somebody else has a better idea. But that's what I've done. And it seems to work just fine. I mean, it doesn't work for private methods or anything, but it works for protected stuff. And I found that a better solution than making the test up. You could make the method community and make the test a friend of the class. But then also, if you want children to be able to use it, then you need to make it protected. So it's, I don't know, that's just the way I've done it. And it seems to work best. Other questions? Yeah, so how do I decide what input conditions to test? That's a really good question. So to start with, I pick the ones that I expect, right? So if I expect a certain value, I'll put that in and test that, because that one's easy. And then testing for abnormal conditions, yeah. So for doubles, you know, test 0, test positive, negative, fractional, infinite, nan. For integers, right, test, you know, above and below. And yeah, I just kind of, I don't really have a good answer for that one, Stefan. What I would say is if you're getting started with unit testing, don't let that daunt you. Pick the ones you expect, run tests for those. And then if you run into issues, you can always go back and add more tests. So when you're starting out, don't get obsessed with getting 100% test coverage. And there's another piece of advice too. When you're starting out, it's easier to start learning unit testing by starting a new project and starting it by writing the test first than it is to take an old project that you have and try to test it. Because chances are it's probably not written in a way that makes it easy to test. And you're going to spend a lot of time refactoring and changing things to try to get it into a point where you can actually test it. So, you know, it'll be an exercise in refactoring, not so much in learning how to test stuff. We still got 5 minutes of some, those are some good, okay, I got your message, Chris. Thank you. We will talk later. That actually, what you said just struck me, and I think that's a cool, there's probably some very good ideas with that. Cool. Oh, I kind of see where you're going with that, Chris. Yeah, we will definitely talk later. Okay, Christian. So if you have a test in a vector like that, would you use a loop? So that you can actually use a loop. Yeah, so you can do that in a loop if you want, Christian. That, you know, put in an array of values and then do that. That is totally a valid way to do it. Yeah. I want to say if you read the unit test patterns book, it calls it like a parameter, not parameter method. What is it? What do they call it? There's a name for that pattern. So yeah, that's totally valid. The one thing you run into with that, Christian, if you do it that way, is that then when you run your test, you just have one test failure, right? And so if you've got if you say for Stefan's thing earlier, we're like, okay, I've got a double input. I'm going to run nan, infinity, positive, negative, 0, right? Well, I put all those in an array and I run them through my test. Well, I get one test failure. Well, which one failed? Is it because I'm not handling nan correctly? Or is it because I'm not handling negative numbers correctly or positive numbers, right? Tips for running tests on a CI build. Okay, let me scroll back. This VI is what you want to call, and you want to call it, I'm using the LabVIEW CLI tool. There's a GCLI tool that James McNally wrote that will also do it. And basically, there's a thing to run a custom VI. So you just create a wrapper for that that parses all the stuff you pass in through the command line and does it. Yes, so Chris, it's not the same paradigm as the UTF. There's nothing stored in files. It's all block diagram constants. So yeah, UTF does, I think they're CSV. So you're having issues running it with the JUnit test runner. Okay. There is, if we go back here, I've not used the JUnit test runner, but there is a thing here to generate JUnit XML test results. Excuse me. So you may want to look at that, because if you're using a JUnit test runner, you might be expecting the results in a certain format. And so maybe you need this JKI tester, JUnit XML test results. I'm using it right now, calling it through LabVIEW CLI, and it works really well. And I use GitLab is what I use for continuous integration. So, but yeah, just try running it from the command line and see if you can get it through the command line using the CLI. Viewing test results in GitLab. I want to say, so when you call this VI, this run test, it gives you some text out, and using the LabVIEW CLI tool, you can pipe that back out to the command line. So GitLab shows you the command line results, so you can get results that way. You can also take those results and maybe using this JUnit tool that I just mentioned, or some other tool, you can write those to a file. And then in GitLab, you would just make them an artifact. And if you make them an artifact, one thing to be aware of is your test will, by default, if the test fails, it won't grab the artifacts. So you got to go in and set it to grab artifacts even when on failure. Because I ran that, I was like, oh, well, test failed. Okay, great, I'll go look at it. And there's no artifact. So that's one thing to be aware of. I don't know other things how that works. So yeah. Any other questions before we go? I can stick around for like another minute or two, but I got to get going. All right, well, hopefully all you guys found that really useful. And yeah, I'm thinking the next one will be something on continuous integration, maybe a replay of what I did at an iWeek. I think that would kind of fit nicely with the progression that we're doing. So it'll be in August. I want to say the last Wednesday, but I'll send out some emails and let you guys know. So, all right, perfect. All right, well, thank you guys. I appreciate you guys all taking some time out of your day to watch this, and hopefully I provide some value to you guys. So, all right, thank you. Oh, oops.